Taking the work I did with my PhD on debris discs and then the research I did working with the Dunes Consortium with Herschel data, what I'm looking at is dust around stars. Yep. And therefore, in order to be able to characterise this properly, you need to be able to understand what the star's doing, which mostly emits in the optical and near-infrared, and you also need to understand what the dust is doing, which emits in sort of mid-infrared, far-infrared, and what's known as the millimetre and sub-millimetre, so very long wavelengths. In the beginning, you have a molecular cloud, and in that cloud there are slightly overdense regions, which are cloud cores. Now, at this point, you get the sort of the protostar forming in the middle as a gravitationally bound object, and you get this big sort of disk all around it. Inside this disk, this sort of circumstellar disk, there is also planet formation going on. This is called a protoplanetary disk. So the dust that's in that circumstellar disk, up to kind of sort of micron-sized particles, then going on to sort of millimetre-sized pebbles and boulders, and then eventually you kind of get up to the stage where you've got kind of what we call planetesimals, but these are kind of like stuff like the asteroids and comets in the solar system. You get large kind of kilometre-sized, so it's about 100 kilometre-sized bodies, and these are the building blocks of planets. And these exist inside the gassy disk as it evolves around the protostar. And eventually gravity takes over, and these things collide and they grow up into a protoplanet. You get sort of two types of planets. You get three types of planets. You get little rocky terrestrial worlds like the Earth and Venus. You get your big gas giants, like Jupiter and Saturn, and you get in between that, you get your ice giants, which are things like Uranus and Neptune. Most of the, what we call sun-like stars, they've been a favourite target for exoplanet searches. By taking a picture of the disk, and so knowing from the image where the dust is around the star, then relating that to the models we have of the emission that and what we'd expect to infer just from the models of the emission, and then sort of combining those two together and saying, well, how does this change our view of what the dust is actually made of and what the dust properties are? Once we know where we're looking, how does that influence our modelling, and then sort of a cyclical approach, iterating down to derive the best physical properties for these systems.